Hi friends, welcome to Programming Languages for Civil Engineering Students channel. In this video, I will discuss how to design the building components by using a powerful tool, that is Excel. Okay, already we have seen what is the purpose of programming languages. Okay. Similarly, this Microsoft Excel is very powerful tool. Many civil engineers, many contractors, many builders, they will use this Excel to design their building components, to calculate the rates, to calculate the bar bending schedule, and everything we can do with this Excel. If those who are unable to have programming languages, or some are unable to write codes in the programming languages for building components, just you can write in Excel file. You can see this is the Excel file. Okay, this is the Excel file. I have developed this Excel file for design of one-way slab. This is a generalized design of one-way slab. You can see here the cleared span is equal to 4.5 mm, 4.5 meters, and the wall thickness is 230 mm. Wall thickness, that is support wall thickness, is 230 mm. The live load is 3, and this is the inputs. Okay, this is the dimensions, room dimensions, Ly, Lx. Okay, Ly, Lx. Then you can see here we can use in Excel if clause, if condition. If Fi, what is Fi? Fi is this. If Fi, that is Ly by Lx greater than 2, then that is designed as one-way slab. Otherwise, if the condition is false or not true, then go for design for two-way slab. See, we got the condition as 2.43 greater than 2, that is designed as one-way slab. Okay, then you have to find the thickness of the slab. You know the effective depth. Effective depth is 180. How we can find effective depth? Generally L by D ratio is 25. Okay, L by D ratio is 25. So in that formula we have input everything, then we'll get 180. Effective depth of the slab is 180 mm. Then clear cover is 20 generally for slabs. Then use of bars. Okay, use of percentage, the use of dia bars, that is 12 diameter. You can use 10 also, 10. Okay, then gross depth is 205 meters. Okay, you know how you can find this gross depth. Gross depth is equal to 180 plus 20 plus 10 by 2. Okay, this is the way to find the gross depth. We can see center to center. Then we have to find the effective span. Effective span, center to center supports. Okay, then clear span plus D effective, that is depth. Then we will get the L effective. L effective is 4.68. 4.68. Okay, less than of these two, whichever is lesser value of this, or 4.73, 4.68, lesser of these two values, that is 4.68 meters. Then self height of the beam, automatically it will calculates, and factored shear force and bending moment. See, this is the factored shear force and bending moment. So we have the constants for grade of steel 250. The constant is 0.148. For 415, 0.138. 500 grade of steel, that is 0.133. This is the constant. We have to write the constants like this beside. Then accounting to our if C7 greater than 500. If C7, what is C7? Our C7 is this. You can see our C7 is greater than this 500 then E30, that E30 is, you can see E30, otherwise E33, no, that is E31, then we'll get whatever, okay, less than means we'll get 450, okay, or 0.133, like that. Okay, the minimum, this is the formula, okay, minimum, D minimum required, okay. The ceiling, just like in MATLAB, then in MATLAB we use CEIL, but in this Excel we use ceiling. Same almost 50% of the commands used in Excel is same as in MATLAB. Okay, okay, everything is okay, everything is the minimum required is sufficient. Then tensile reinforcement. Then if you want to find the main reinforcement, the AST is equal to, this is the formula. Okay, this is the formula. Minimum reinforcement is this. Minimum reinforcement is okay. It is okay. Then use dia of bar is 10. I use 10. Spacing of reinforcement is, main reinforcement is 135 mm. Maximum spacing is 540, and whichever less, that is 300. And spacing to be provided is, as usual, this 175. Okay, 175. Then for distribution reinforcement, you can see here the distribution reinforcement AST is 0.12 percentage of gross area, means in gross area with slab per meter. Okay, per meter, we will take per meter in slab. Then use of dia bar, okay, let us say I am using, let us say 10. Okay, 10. Then spacing is 320 mm, maximum spacing is 900 and 450, whichever is smaller we have to take. Spacing is 450, and provide these 320 mm center to center. This is the spacing. And check for deflection. Okay, you can see check for L by D of for SS slab, simple supported slab, that is 20. Okay, in this way we can find, okay, you can write your own code in Excel, then to design the building components. Just like you can see, this is footing. You can find footing also similar way. You can find footing, also design of footing. Similarly, silos, design of silo. Okay, design of silo, we can also design the silos. Okay, it is very time consumed, but in Excel or any programming language, it takes within seconds to design. Okay, then column design, you can see here, this is the basic column design code. You can see breadth, I will take 300. Okay, 300. Design for short column, design for short column, design for axially loaded column. Okay, axially loaded column. And you can see calculation of the steel. Minimum reinforcement is 840, and maximum reinforcement is this, that is 0.6 percentage of gross area. Then diameter of the bar, I used the 16, and bars to be provided. Bars to be provided is 6 bars. Okay, let us say I am taking some 12 diameter column reinforcement main bar, as we have to provide 8. Okay, 8 main dia bars. Then lateral ties, diameter of the lateral tie is, diameter of the lateral should not be less than, means generally 8, we have to provide 8, there is no doubt about that. 8 mm. Then spacing of lateral ties, you have to find the now spacing of lateral ties. So you can find lateral spacing, just I use 180 center to center, we got 192. We can provide 180 center to center spacing, lateral ties. Okay, this is all about brief how to design building components by using Excel, those who are not interested in programming languages. Okay, if you have any doubts, please comment in the comment box. Okay, anyway, thank you for watching this video. Thank you.